Today in this video, I'm going to go over slightly harder problems for both static friction and kinetic friction types of problems you will most likely see on your exam. So I'm going to go through each problem, try to pause the video, see if you can solve it on your own, and then you can watch how I solve it and check your work. All right, so let's get right into it. So we have an example. We have a 5 kilogram box which rests on a 25-degree inclined plane. So we have a plane like this. We have a box that rests on it. The box is 5 kilograms. Oops. And the angle is 25 degrees. The coefficient of static friction is 0.5. And remember, the coefficients of friction are always unitless. And I want to know, will it slide down the ramp? Will the box slide down the ramp? So go ahead, pause the video, try to solve it on your own. If you are confused on how to do incline problems, check out one of my previous videos. I did a whole video on solving inclined plane problems. But go ahead, try it on your own, and then I'll work it out. All right, hopefully you had a chance to solve it. Let's get right into it. So first step with any problem, let's go ahead and draw our free body diagram. So we have our block, we have our normal force going up, we have our weight force going down. This is also mg. We know that we want to know, will it slide down? So we need to find this. We know there's friction upwards, so I'm going to say there has to be friction static going up, and there has to be some sort of force going down. But this force, we weren't told that anything was applied. So this force is going to come from the weight force. So we can split the weight force into two components. This one and that one. So this is our weight parallel, and this is our weight perpendicular. Again, this is our theta. Oh, I'm so sorry. This is our weight perpendicular. This is our weight parallel. Perpendicular to the surface, parallel to the surface. And that is our theta, which we get from here. All right, so our weight parallel is equal to mg sine theta, which if we plug everything, m is 5 kilograms, g 9.8, sine of 25, we get that this is roughly 20.73 newtons. And our weight perpendicular is just mg cosine theta. And if we plug everything in, we should get that this is around 44.39 newtons. So let's go ahead and find our maximum static friction, because we want to know, will it slide? We don't care about acceleration or anything. We just want to know, will it move? We know that our weight parallel is this one right here, is opposing where the friction is. So this is equal to our weight parallel. So we want to know, is the coefficient, or is friction static greater than, equal to, or less than weight parallel? If it's less than, then we're moving. If it's greater than or equal to, the box is not sliding. So let's go ahead and find the maximum static friction. And if you remember the formula for that, this is equal to, this is max mu s times n. And to solve for n, because there is no vertical acceleration, and let me draw my coordinate system like this. So there's no acceleration in my y direction. So then I can get that normal force is equal to weight perpendicular because there is no acceleration. And this is from Newton's second law in the y direction. All right, so I know normal force is 44.39 newtons. So applying that to this, plugging it into here, we get that our static friction maximum is roughly 22.2 newtons. Again, plug in our US and N. So here we see that our friction static is equal to 22.2 newtons, and our weight parallel, which is the force that will be pushing the block down the ramp, is 20.73. So F of S is greater than the force trying to the force that will make the object move, or the force that is causing a tendency to move. So this tells us that block won't move. And that's our answer. So it will not slide down. And this is our justification. Another important thing to remember is, let's go back to our formula for static friction. So for static friction, remember that it's F of S is less than or equal to mu s n. And see how our static friction here, so if our maximum is this 22, it is but our force applied is less than that, right? So in this case, our force static friction is equal to what the force applied is, right? It cannot be greater because the block is not sliding up the ramp, right? So to make a note, our actual static, so that is our max, our actual static friction is equal to our weight parallel, right? The block is not sliding, right? The static friction moving the block up the ramp is the same as the weight pulling it down the ramp. But our actual static friction of 22.2 newtons is less than the maximum static friction, that transition point that I talked about in my last video. And that transition point is 22.2. So that is how we know if the block is sliding. Hopefully that made sense. Let's try one more problem. And this will be a kinetic friction problem. So again, we have a 5 kilogram block sliding down a 30-degree incline. So we have 5 kilogram block sliding down. So we know acceleration is not 0. And this is 30 degrees. Find the acceleration. And mu k is equal to 0.25. So go ahead, pause the video, try to solve it on your own, and then we'll go ahead and get into it. All right, hopefully you had enough time to solve it. And I'm going to get right into it. So first things first, we're going to start with our free body diagram. I'm going to say y is perpendicular to ramp, x is along the ramp. So we have our block. We have our weight going down, so this is your weight perpendicular, weight parallel. We have our friction, kinetic friction, opposing motion, so up the ramp. We have our normal force, and that's it. All right, so let's go ahead and find our normal force. So we know there's no acceleration in the y direction. So we know that normal force is equal to weight perpendicular, because only if we do sum of forces in the y direction, we get normal minus weight perpendicular, and this is equal to 0. So normal force is equal to weight perpendicular, and weight perpendicular is similar to here, mg cosine theta. And if we plug everything in, we get that normal force is equal to 42.43 newtons, or roughly about that. All right, once we have normal force, we're going to plug it into our kinetic friction formula, which is just mu k times n. Mu k is 25.25 times n. We'll substitute that in. We get kinetic friction is equal to 10.61 newtons. All right, so we know how much the friction force is, but let's find out, well, we need to find out acceleration. In order to find acceleration, we still need to find how much force is moving the block down the ramp. So we need to find weight parallel, and this is mg sine theta. When we plug everything in, this should be 24.5 newtons. All right, so now we have our force to the left, we have our force to the right. Now let's apply Newton's second law in the x direction. X direction, because of our coordinate system, that is the only direction that has acceleration. So force in the x direction is equal to mass times acceleration. Our sum of forces will get, we have down the ramp is positive, so we'll have 24.5 minus 10.61 is equal to 5 kilogram, times A. Rearrange this, and we get acceleration is 2.78 meters per second squared. And there you go. That is how we solve slightly more difficult kinetic friction and static friction problems. This is most likely how it'll be on your exams. So hopefully that helped. And if you're still confused, watch my previous video where I explain the basic concepts of both these types of friction. All right, good luck, and I'll see you next time.